This is a problem related to automatic transmission torque converter that is sits in between the engine and the transmission, and this is a perfect example of pump motor combining together. Um, so you can read this description, basically some background information about torque converter, how they work or how they're connected, things like that. I have simplified the problem here. So you got the engine, the torque converter, and the transmission. So this is how this thing is connected. It says that the torque is 253 speed given for both the torque converter and the um, so for the torque converter has one, it's a one single piece. It has both the, let's get my pen. It has both the impeller and the motor. So it's just a single piece. So one side is the pump side, which is connected to the engine. Actually, it is fitted the opposite way. However, for the simplicity of understanding, we're just gonna think this way. So this is the motor side. So then you have all the information given here on the pump. It gets 253 torque, pound-feet of torque, and the engine power is available 253. However, you should always calculate that based on the torque and the speed, what the power is taken by any hydraulic system. So instead of using directly, and first of all, they shouldn't be same. They should be same at the speed of 52. Now, the calculate the power taken by this torque converter. So if you just write the equation like this, P equal to Tn divided by 52, like that. So you can calculate that. So our torque is given 253 pound-feet divided by the times 3100 RPM, then 52. I have got this number 149.3 horsepower. And then says calculate the power delivered by the torque converter. So it's a 30% efficient, very less efficient at this configuration. So we can say the overall efficiency is the power output divided by the power input. So that is the efficiency is 30%. So we can say power out. We can calculate that by the input, which is this much horsepower. So I have calculated the power out is 44.8 horsepower. Now let's go to the next question. Calculate the torque delivered by the torque converter. So we know the power. So we can write this equation again. P equal to Tn by 52. So for the power, I got 44.8 from the previous question is equal to torque output by the converter times the RPM. The converter is the motor side is running at 300 RPM. So that's divided by 52. So torque output is calculated 784. That's what the automatic transmission does, is multiply the torque by sacrificing huge efficiency. Calculate the flow rate developed by the pump of the torque converter. So we can say the theoretical flow rate is VD, volumetric displacement times the RPM. The volumetric displacement given is 2 quart. If we go back to the problem, it is given 2 quart. 2 quart is half gallon. So you can directly use that gallon. So you can get it gallon per minute. So 2 quart is half gallon. And that is per every rep. The volumetric displacement is given typically in one revolution how much fluid is displaced. And the pump side of the torque converter is rotating at 3100 rep per minute. So then I got it 1550 gallon per minute output. Sorry, the flow developed by the pump. theoretical flow, and then calculate the flow rate developed by the motor. So we can do the same thing. The motor volumetric displacement is also given 0.5 gallon, which is 2 quart given. So that's 0.5 gallon per every revolution times the motor is running at 300 rpm per minute. So I calculated that. That's 150. I don't need a calculator for that. 300 divided by 2. So 150 gallon per minute. Then calculate the pressure developed by the pump side of the torque converter. So we can just simply do power is equal to PQ by 1714. So we can plug all this number. So power taken by the pump was 149.3 horsepower, and then the pressure will come in PSI. If we use this, so the pump flow was developed 1550 gallon per minute. Assume that there will be no volumetric loss. Otherwise, we cannot solve this problem. Volumetric efficiency should be given for this problem. So we are assuming that the volumetric efficiency is 100%, no loss in terms of the fluid. You can imagine things like whatever fluid goes in kind of deliver. It doesn't work that way. There are some slippage and loss always. However, assume in this case 100% efficient. So then P, I calculated that, what's that? 165.1 psi. That's for the pump side of the torque converter. Now calculate the pressure developed at the motor side of the torque. Same thing at the motor side, I have less power because motor is losing efficiency. So motor side, I don't have that much power. So we can, that was calculated 44.8 horsepower P, and the flow rate of the motor is 150 gallon per minute. I calculated that before. Divide by 1714. Again, I'm assuming that the volumetric efficiency is 100%. So the pressure I calculated, I hope my calculation is correct, 512. I thought that should be smaller, but that's what I got, 512. So that's it about this problem.